Hey everyone, so here's another example of the surface area of composite solids. So in this case, which is different to the L-shaped one, we now have cylinders involved, which is like a prism, but we know a formula for the area of a cylinder. Surface area of a cylinder. So the surface area of a cylinder, sorry, I got the wrong setting on. Let me just change that. Okay, so the surface area of a cylinder equals pi r squared, so 2 pi r squared plus 2 pi r h, okay? With the two circles, the circular ends here, and the curved section here. Okay, so in this case, what I'm going to do is I'm going to use option 1, okay? I'm going to use option 1 because I'm going to use the faces, okay? It's going to be hard to do the perimeter of this because it's a circle. Like, I know the perimeter of a circle is a circumference. You can use that, but we have the formula for the surface area of cylinders, so let's use that. Okay, so option 1 is our first step is to find all the faces. So, identify faces. Okay, so the faces that we have to find the area of the identical ends. Okay, so the identical ends. And the shape of the identical ends is actually an annulus. Okay, so an annulus, the area of an annulus, if we remember rightly, is pi, the bigger one squared minus the smaller radius squared. Okay, we're going to use that to find the area of the identical ends. Then what we've got to do is we've got the other faces. So we've got the curved edge around the outside. We've got this one around here. And then we've also got the one on the inside, like in here. Okay, so we've got the outer curve. And we've got the inner curve. Now we have to find the area of each. Okay, so let's find the area of each face. Okay, so the top face is the area of the top face is pi, our bigger radius, 20 squared minus 15 squared, and the closed bracket. And because there's two of those, we're going to times this by 2. Okay, I'm going to leave this in exact form so that it will be easier to work with later, and we don't have any rounding issues. If you do round, that means that you may get like slightly different answer when you look at the decimal places. Okay, so just be careful of that. So this is 350 pi. Okay, I've just did 20 squared minus 15 squared, and then I've times that by 2, and then just put the pi at the end. That's how you leave it in exact form. Okay, so the outer curve, to find that, you need to look at the surface area of a cylinder formula and use this section here. Okay, so our radius of the outer curve is 20, so we're going to do 2 times pi times 20, and then we're going to times that by the height of the cylinder, which is this section here. Okay, so how tall it is. So I'm going to times that by 36, and I'm going to leave that in exact form again. Okay, so I'm going to do 2 times 20 times 36, and that's 1440, and then pi at the end. Okay, our last one is our inner curve, and we're going to do the same thing. It's going to be 2 times pi times our inner radius, which is the one from the middle going to the smaller part, 15 times 36. Okay, leaving it in exact form again, we're going to do 2 times 15 times 36, and that is 1080 pi. Okay, so now that we've found all of the faces, the area of each of the faces, we've got to add those together. So our step 3 is to find the total surface area. Okay, by adding them up. So our surface area equals 350 pi plus 1440 pi plus 108 pi, which equals, I'm going to do 350 plus 1440 plus 108, which equals 1080 pi. Okay, and I'm going to leave that in exact form. Okay. Okay, in the Google form, you're going to have a choice on whether to leave it in exact form or not when it comes to cylinders. Okay, and any other sort of circular 3D shape like cones and spheres. Okay, if you have any questions, please go to Jamboard. I'll be waiting there for you. Okay, good luck with the questions.